Okay, so next we're going to talk about the 7 steps to graphing rational functions. These right here are the 7 steps to graphing, and I already have an example written up there that we're going to work out. But before we do it, let's go ahead and go through what the steps are. The first thing that you want to do is find the domain. The next thing is find the vertical asymptote. Step 3 is find the horizontal asymptote. Step 4, find the y-intercept. By doing that, you plug in 0 to all of your x's. So you're finding f of 0. Step 5 is find the x-intercept. To do that, you solve p of x equals 0. And then step 6, graph your vertical asymptote, your horizontal asymptote, your y-intercept, and your x-intercept. And step 7 is the final step of graphing, accuracy points. So you're going to find 1 point to each side of each vertical asymptote and x-intercept. Let me zoom in on that real quick. So step 7, accuracy point. Find 1 point to each side of each vertical asymptote and each x-intercept. Okay? All right, so let's go ahead and work through the steps. And as we work through the steps, you will see how we do that. Okay, so first, domain. So you take your denominator, x squared minus 9, and we've been setting it not equal to 0 because we're looking for basically what x can't be. You can factor that or however you want to do it. If you factor it, x plus 3 times x minus 3 can't be 0. So x cannot equal negative 3 and x cannot equal positive 3. Don't forget to put it in the right format. So here we are going to use set builder format. So that should be the set x, where x cannot equal negative 3 and x cannot equal positive 3. Okay, let me zoom in on that for you so you can see it a little bit more closely. So domain, x cannot be negative 3 and x cannot be positive 3. Okay. Actually, let's do this for the vertical asymptote also. So your vertical asymptote really works from your domain. The only possibilities you have for your vertical asymptote are going to be the items that your x's can't be. Okay, now it's not always all of them, but those are the only possibilities. If it's not in this list of x can't be, then it's not going to be in your vertical asymptote. Okay, so for vertical asymptote, remember the first thing we had to do was we had to factor the numerator and the denominator. Okay, well the nice thing is by finding the domain we did the factoring. We didn't have to, but we did. So our equation is actually f of x equals 4x squared over x plus 3 times x minus 3. The reason we do that is to see if anything cancels, and we cannot cancel anything. Because in order to do your vertical asymptotes, you have to have your function in simplified form. Okay? So this is as simple as it gets, nothing cancels out. So our asymptotes, we actually have 2 vertical asymptotes, because now you take your denominator, this right here, this is your q of x, you take that and you set it equal to 0 and you solve. We've done this numerous times, so we know that x must equal negative 3 and x must equal positive 3. It's the same numbers that are in our domain, but this time we're saying that they equal them because that's where we're drawing a line. Okay. So next we're down to horizontal asymptotes. Zoom back out so we can see it. So for the horizontal asymptotes, we use one of our 3 rules that we had. If you go back to your rules, so in this case, you're only looking at the equation right here. So we're only looking at the 4x squared over the x squared part, and we're using these exponents. So since 2 equals 2, that means that n is equal to m. So that means we have the equation y equals, we divide our coefficients. 4 over 1, which is just 4. So our horizontal asymptote is y equals 4, and that is it. All right, let's move over to the other side. So we have finding the y-intercept, finding the x-intercepts, and then we're going to make our graph. smoothing that a little bit. Okay, so to find the y-intercept, you just plug in 0 to all of your x's. So f of 0 is going to be a 0 in the numerator, 0 minus 9 in the denominator. So that just gives us 0. So we get the ordered pair 0, 0. Right here, find the x-intercept, p of x equals 0. We're going to solve it. If you remember, the format of the rational function is f of x equals p of x over q of x. So we're going to solve the numerator. Okay, so 4x squared equals 0. So that just means that x has to be 0. So again, we get the ordered pair 0, 0. And now we need to move on to the actual graphing. Okay, so I'm going to jot down real quick what we had so I can use that other space in the board. Vertical asymptote was x equals 3 and x equals negative 3. Horizontal asymptote was y equals 4. Okay. So now let's graph. So I have my coordinate plane. Make sure you label your axes with x and y. Okay. So I'm just going to plot them. Our vertical asymptote is at positive 3. And make sure you write down the equation of that. X equals 3, negative 3. X equals 0 for our x-intercept. Y-intercept is y equals 0 or 0, 0. And then we also had our horizontal asymptote at y equals 4. So that's just a horizontal asymptote right here. Okay, and there's step 6. We've got everything plotted. So now we need to go on to step 7. Step 7, we need to actually make a table. So with this little table, and hopefully I won't run into that space, I need to look at my x-intercepts and my vertical asymptotes, and I need to plot to each side of those. So from here, here's my negative 3. I'm going to use an x to the left and an x to the right. So that's going to be negative 4 and negative 2. Those are what I'm going to plug in. Then I look at my x-intercept. I use an x to the left and an x to the right. So that is negative 1 and positive 1. Then I go to positive 3, and I use an x to the left and an x to the right. So that is 2 and 4. And I just simply plug all of them in. You can do your work on the side. Our equation was f of x equals 4x squared over x squared minus 9. So I just plug them in separately and write down my work. So let's see, that's a negative 16 to the 4th is, so I get 64 over 16 minus 9, which is 7. 64 sevenths right here. Plug in negative 2, and that's going to be a 4 times 4, which is 16 over 4 minus 9, which is 5. Can I pause it? Okay, so when we plugged in negative 2, we got 16 over 5. We plug in negative 1, that's going to be a 4 over 1 minus 9 is negative 8, so that's negative a half. And I'm just filling that in my table. Plug in a 1, that's actually going to give me the same thing. So that gives me negative a half. Plug in positive 2, I get the same as negative 2 because anything squared is positive, so I end up getting exactly the same thing. So that's going to be 3 1/5 again, and then plug in positive 4, I'm going to get 64 sevenths, which I actually figured out is 9.1. Okay, so just a little bit higher than 9. So now we need to plot all of those. I have to see up to 9, so I have to raise this. Here's 8, here's 9, here's 10. Okay, so negative 4. Negative 4 is here. I'm going to go up to 9.1. So right there. So what that means is my graph is going to be in this section. Okay, I'm approaching each of these asymptotes right here. They're kind of like magnets. They're pulling the graph towards them. Then I have negative 2, 3.5, so that puts me here. I have negative 1, negative a half. Negative 3.5. I have 1, negative a half. Oh, I bet I have that. I bet I do have that backwards, because that's weird that this is going to go like that when we've got an asymptote there. So let's double check our multiplication. So if I plug in a negative 2, negative 2 squared is 4. 4 times 4 is 16. And then a negative 2 squared is positive 4, subtract 9. That actually gives me negative 5. So instead of my point being up here at positive 3 1/5, it's actually down at negative 3 1/5. Keep that in mind, because you shouldn't be shooting through a horizontal asymptote. You might bounce off of it, you might kind of oscillate kind of by it, but you're approaching it, you're not going through it. So these should be down here. There we go. That's better. So now it's like a parabola in the middle. And that makes a lot more sense. Okay, so now the last one at positive 4, we're at 9.1, so we're up here at the top again. And then we're just going to make that branch stay in that upper right section right there. And that is the 7-step process for graphing a rational function.